A Portland Community College Mathematics telecourse. A course in arithmetic review. Produced at Portland Community College. As we begin this lesson of changing decimals to percents, again bear in mind we're merely changing the way we write a number. We are not changing its value in any way whatsoever. Keep that idea firmly in your mind as we work our problems. Example, change 0.35 to a percent. On all of these, the question is, how many hundredths is that number? Well, of course, 35 hundredths. Okay, let's say it. 35 hundredths or per hundredth. So again, this mark is merely a way of saying how many hundredths do you have? 35 hundredths, 35%. Well, here we have 7/10, but to change it to a percent, we need hundredth. Well, one of our basic rules of decimals was behind the decimal point on the end I can append as many zeros as I want without changing the number value. But now I have tenths, hundredths. In fact, I have 70 hundredths. So again, percent is simply another way of saying hundredths. Now in a problem like this, it's not quite so obvious. I could append the zero so that I have a hundredths, but there's a tendency to say that I have 30 hundredths. But what about this 2? This 2 is 200 hundredths. So really this would be 230%. But that's not quite so obvious as our previous problem. So let's make this observation. Had I started with the decimal point and moved my decimal point 2 places to the right, or if you wish, towards the percent sign I wish to put on, and then insert zeros if extra places have been created, I would end with 70%, which was my result. So that simple rule might be a more convenient way of looking at it. To change to a percent, I move the decimal point 2 places to the right, or if you will, 2 places to the percent sign. And that's my percent. And of course, stick the percent sign on. Let's verbalize that. To change a decimal to a percent, first make sure the decimal has digits at least as far as a hundredths place. Then move the decimal point 2 places to the right, or if you will, towards the percent sign, to the percent sign, then write in that percent sign. 2 places to the right, write in the percent sign. Now applying it to this problem becomes a little bit more obvious. Make sure it has decimals at least to the hundredths, we did. Move it 2 places to the right, and that would give me 230. Stick on the percent sign. We're done. A simple rule. In a problem like this, it already has more than enough decimals. So we move the decimal point 2 places to the right, which would give me 8.32, and stick on the percent sign. If the phrase to the right bothers you, then think I'm going to move it 2 places to the percent sign, and then stick the percent sign on. Again, as you do these, always remember that the number value is not being changed. Just its form, its appearance, another way of writing the same number. Now sometimes the beginning student, just because the given numbers look different, thinks that he has to do something different. But remember, our rule is always the same. 2 places to the percent, and stick the percent sign on. 2 places to the percent, and stick the sign on. Place towards the percent, and stick the percent symbol on. Now in this one, it looks like there is no decimal to move, but remember the decimal point is always to the right of a whole number. Then move it 2 places to the right or towards the percent, and stick the percent on. Now in this case we got a decimal percent, a small percent, very large percents. But don't let that tempt you to try to break the basic rule. Always 2 places towards the percent, and stick the percent sign on. And whatever you get, you get. If it's a very small decimal or a very large number, that's just the way it happens. Even if you have a decimal with fraction, nothing changes. Move the decimal point 2 places to the right, and write in the percent symbol. 2 places to the right, and write in the percent symbol. 2 places to the right, and write in the percent symbol. The fraction just stays on the end as it did here. Only the decimal point has moved. And of course the decimal point behind a whole number really isn't necessary. So the basic rule of moving the decimal point 2 places to the right never changes. Summarizing once again, make sure the decimal has digits at least as far as a hundredths place. Move the decimal point 2 places to the right, and write in the percent symbol. Let's say the same thing in street language. A little bit crude grammar, but it's a form that students find easy to remember. When changing to a percent, you move the decimal places 2 places to the percent and stick on the percent symbol. That idea you're changing to a percent will always remind you you're moving it to the percent if you're trying to change to a percent. Sort of an overuse of the word to, and in fact we're moving 2 places too, aren't we? But when we compare this with future lessons, this will help us keep our mind clear between this and several other processes. Now note, we're moving a decimal point in order to use this new notation. Our choice of digits, the fact that I have 4 here, the digit 4, in each of these 3 problems, has nothing to do with it. We're concentrating only on moving a decimal point. So if I move this 2 places to the percent, of course if I create an extra spot, I fill it with the placeholder 0 and stick on the percent. This one, move it 2 places to the percent and stick on the percent. Here, move it 2 places to the percent, but I don't have anything to move. So we remind ourselves that with a whole number, the decimal point's always on the right end. Now, if we move it 2 places to the percent and fill in with placeholder zeros, 2 more in this case, we get 4,000%. So the percent might end up being a fairly normal number relative to what you expect to see in your daily lives. It can be an unusually small decimal number as well as have the percent, and it can be an unusually large percent. So don't change your answer just because the answers look strange. Just ask yourself, did you follow the rule? Did I move the decimal point 2 places towards the percent in every single case. If the answer is yes, then you must be correct. And if it looks strange, well, it simply looks strange. But also remember that we said move it 2 places to the percent and stick on the percent. Many people will forget that, and it's very important to realize that the number 40 and the number 40% are 2 different numbers. In fact, this is many, many, many times larger than this. The 40% is just another way of saying 4/10, and 4/10 is 100 times smaller than 40. Therefore, never forget, this is the number, not that. Now, that could be a number, but that number is not the same thing as that number. Just as with decimal points, you would never want to look at this and think that that's the number 25. It is not. This is part of the number, which changes this drastically from 25. In fact, this is a symbol for decimals, but the hundredths decimal. So if we wanted to change this to a percent, we would move the decimal point 2 places to the percent, and of course stick the percent on. So this number, 2.5%, and this number, 25 thousandths, are in fact the same number, just written differently. It's very important that you have that idea crystal clear in your mind throughout this chapter. And that applies to all situations, irregardless. So if we have a decimal with a fraction, we wish to change it to a percent. First you find the decimal point, and you move it 2 places towards or to the percent, and where it ends up, it ends up. And then, of course, stick that percent sign on. If I didn't have this, this would not be equal to that. This is now a different number. It's 100 times larger. But as soon as this symbol is there, it's telling me that this is just another way of saying this. Let's do a couple more of those and see how this sometimes will cause us to think a little bit, but to never change the rule of 2 places towards the percent. Now let's do another one. Notice in this one we had the decimal with fraction at the thousandth place. Here we have a decimal with fractions at the hundredth place. But if we're changing to a percent, the rule is to change 2 places to the percent, towards the percent, and that rule never, ever changes under any consideration. So if I move this 2 decimal to the percent, toward the percent sign, this becomes 42, and of course point, which I don't write, and then the 3/7 is already there, and then of course stick on the percent. So please note again and again, this is not the answer to this question. This is the answer. This is part of the answer. It's part of the number. Okay, so our rule again, move it 2 places to the percent, always and forever, never a single exception. Here's a form that will cause us to think a bit. Again, the rule, if you want to change to a percent, you move it 2 places to or towards the percent, and we just stated that rule never, under any condition, changes. But if I try to move this 2 places, there's only 1 place, and I've got the fraction here in effect blocking me. I can't go on and stick a 0 there because it says I have 2/3 of a tenth right here. So we need an extra place. And the usual procedure to get there is to go back, take what I have so far decimal-wise, 0.8, then take this fraction and begin to divide it out, because it does, after all, say 2 divided by 3. Now, if this were the only problem, you would recognize the decimal point is here. It would go straight up, and I would begin to divide. 2 goes into 26 times. 6 threes is 18, with a remainder of 2. I could bring down more zeros, in fact as many as I wanted to, or make a decision to stop at a certain place, take the remainder, and write over the divisor. And what this 6 does, be careful, this says 6/10 here, but up here is really 6/10 of 100. So starting from this decimal point, that gives me more digits starting from the end up here. So that gives me one more 6, and then I have 2/3. So now I've divided this, gotten one more digit with a new fraction, and sometimes this fraction, in fact very frequently, will be entirely different than that one. We'll work one in just a moment to indicate that. But the point is, by doing this division, I was able to get one more digit in my hundredths place, and the reason I wanted to do that is if to change to a percent, I've got to move 2 places towards a percent always. And now I have 2 places over which to move it. And I get 86 and 2/3%. So this number is equivalent to that number. This is the decimal with fraction at the tenths place form, and this is a percent with a fraction to the nearest whole percent form. Let's do one more of these. Let's do this one. Again, our problem is I can't move this 2 places to the percent, and I always must. There is no exception to that rule. But in this case, the fraction at the tenths place is stopping the way. So we said dividing 3 by 7 will give me additional decimal digits. So as I do this, 7 into 30 goes 4 times. That's 28 with a remainder of 2. So this 4/10 here actually is going to be 4/10 of a tenth, which is 4/100. Or in short, starting at this decimal point, each digit I get gives me additional digits behind the 5. Then if I wish to quit there, because I now have 2 places in order to move the decimal point 2 places, I can write this remainder over the divisor. And now if I want to change it to a percent, I can in fact move it 2 places to the percent, and of course stick that percent on. Be cautious with this. It's an area where very common mistakes are made very frequently. Let's leave that lesson for just a moment. It's an easy lesson, and spend the last 5 to 8 minutes together and review solving proportions. If you're quite good at solving proportions by this point, you might want to skip the rest of this lesson and go right to your homework. But if you're not, pay particular attention to this review, and possibly over the next few tapes, because towards the end of this chapter we're going to come upon percent story problems, applied problems, where we will merge what we've learned and reviewed from percents with what hopefully we recall from proportions and solving proportions, and we'll be able to solve what otherwise would be rather complicated story problems. But the use of proportions with percents can make certain categories of story problems, which seem to be difficult, really quite simple. So let's review. Let's say we wish to solve each of these proportions, and for the sake of being able to stop somewhere, let's say to these two we will solve to the nearest tenth, and to this third we want it solved to the exact fraction. Let's begin. Really going back to basics, we recall that you take top times bottom, and I'll just indicate it here without doing it. 48 times 39, then set equal to bottom times top, so D, whatever D is, times 22, and since we can't do it, we just show the multiplication as we did here. Okay, so top times bottom, set equal to bottom times top, then concentrate on the unknown, the variable, then divide both sides by the multiplier of the unknown, which in this case is 22, and on this side of the equation. And to recall, the unknown could appear on either side of the equation depending on where in this proportion it was. But wherever it is, you divide both sides by the multiplier of the unknown. And of course here it cancels out, isolating the D, which is what we mean by solving the proportion. So this simply reads now, D is this, whatever that is. And there's no decision there. It's telling us what to do. This times this, divide by this. So if we're using a calculator, 48 times 39 divide 22 equals, and our answer, if we went to the nearest tenth, well, we can see 85 point, and here's a 0 at the 10th place, but the digit next to it is certainly 5 or more, so I would add 1 there, so it gives me 85.1. Then, of course, always look back and see if that seemed reasonable. So let's see, this number is somewhat more than that, almost double that, isn't it? So this number should be almost double that, and indeed it is. So at least the answer is legitimately within the ballpark of what seems reasonable. Then as you gain more practice in the last chapter, and if you had a calculator for sure, we said there is a shortcut which allows you to do everything on the calculator without writing anything down except the answer. We said look for the diagonal that has no variable. So there it is right there. Those are the two you multiply. So 14.2 times 31.5. Then look for the diagonal that does have the variable and divide by the number that's on that diagonal. So divide by 78.9, then hit the equal, and we're done without writing down any work. So again, if we wanted it to the nearest tenth, well, that's 5.66, so it's 5 point, and just to the right of where I want to round is 5 or more, so I round up. So my M is claimed to be about 5.7. Now let's see, 5.7 is quite a bit smaller than 31, but 14 is quite a bit smaller than 78. So this is in the ballpark. And of course, the fastest check is simply to clear the calculator and go again. Multiply these two. Then divide by 78 point equals, and we have it. Again, if you're using a calculator, just simply form a habit of always working a problem twice, at least, because it is fast. And it's very easy to make careless punches on the calculator, as you probably saw me do at the very beginning of this. Then in the last chapter, we warned you about becoming over-reliant upon the calculator, because there are some problems because of the exact nature of it that the calculator, which is basically an approximator in a sense, can't do. As in the case with fractions and mixed numbers. But the rules are still the same. I'm still going to multiply the 2 on the diagonal without the letter, and I'm still going to divide by the number on the diagonal with a letter in order to get, in this case, my value for r. We simply remember that if we're multiplying and dividing by mixed numbers, we changed everything to improper fractions first. So this is 4 and 1 is 5 halves. This one's 4 and 1 and 5 fourths. This one's 15 and 1 16 fifths. Now we simply write down what we would otherwise have done in the calculator. So I would multiply these two, so let's write it down. 5 halves times 16 fifths. So 5 halves times 16 fifths. Then divide by 5 fourths, but to divide in fractions means to multiply by the reciprocal. And now because we're multiplying, look for any cancellation. Then multiply what's left, which is 32 over 5. Then change that to a mixed number, which in this case would be 6 and 2 fifths. So r is 6 and 2 fifths. What's important is to realize I did the same thing here as I did on the previous 2 problems, but I did it with fractions here rather than decimals and a calculator. But indeed, I did do precisely the same thing in all 3 problems. And that's what we want you to review, so that as we come back to this in 2 or 3 or 4 lessons, you'll be very good and comfortable at solving proportions, as well as going back and forth to different forms of percent and non-percent notations. But while reviewing proportions, don't forget our basic lesson. To change to a percent, you move the decimal point 2 places towards the percent and stick the percent sign on. Move the decimal point 2 places towards the percent, and if you create extra places by doing it, you insert the placeholder zeros and stick the percent sign on. Same in this case, but remember that with a whole number, the decimal point's always on the right end. Move it 2 places towards the percent, stick in the placeholder zeros, and stick on the percent. And never forget, these are all equivalent numbers, just written differently. If you have that, this lesson will be quite easy. This is your host, Bob Fennell. We'll see you at the next lesson. Good luck.